We have officially concluded Unit 1, which is intended to give you some of the basics of psychological research, such as, again, understanding how we develop research questions, hypotheses, what are constructs, what are variables, things that are going to be important as we start discussing now starting with this chapter, the various ways and approaches that we actually use to test some of these research questions. Now, with today's content is going to focus specifically on non-experimental research, and as we continue with our lectures for this unit, we'll be exploring various different approaches in depth. On our first lecture, one of the things that we discussed were various approaches to psychological research, one of those being the difference between experimental research and non-experimental research. And the biggest thing that distinguishes these two different approaches is the usage of manipulation. In experiments, as we'll learn in more depth on the next, actually in 2 lectures from now, as a researcher, we manipulate something for the participant. So there's some intervention from the researcher in what the participant is experiencing. In non-experimental research, we lack this manipulation. There's no intervention from the investigator or the researcher beyond simply just observing the behavior as it naturally happens. So this type of research approaches, again, focuses on observing, describing, and exploring psychological phenomena as it naturally exists. Now, both of these approaches are important for understanding of psychological phenomena. They answer different questions, but both types of questions are extremely important for us to, again, have a full picture of any kind of psychological phenomena or human behavior that we're interested in. Non-experimental research is often the most appropriate approach for addressing specific types of research questions. So again, using an experimental methodology many times will not be possible for specific reasons, or again, it's just not the ideal method for the goal of a research question. Now, among some of the reasons why sometimes experiments are just not ideal is going to be considerations like ethical limitations. So when it comes to things like, for instance, traumatic experiences, this is not something that we can tell participants, well, you're going to be in an abusive relationship and you're not going to be in an abusive relationship, and then we're going to compare your mental health at the end of 6 months. Obviously, it's not ethical. We are not allowed to put participants at any kind of risk, especially that level of risk, without, again, having an appropriate risk-benefit balance, as we saw in our last chapter. There are also sometimes practical impossibilities. This is meaning that sometimes it's just not feasible to actually manipulate something. Remember that experiments, the only thing that really makes them different from non-experimental research is this manipulation aspect. So again, there's some things that we just simply cannot manipulate, or we're not able to make those manipulations as strong as we would need them or as consistent as we would need them. So for instance, when it comes to your personality is something that is extremely stable in people, and it's something that, again, it's really hard to manipulate. And sometimes when we achieve to manipulate personality through, again, certain types of manipulations, this is not something that's going to be long lasting. So it's not the most representative observation of how behavior would actually be influenced by personality. And another thing to consider are time constraints. There are some things that, again, Perhaps we could design in a experiment format, but it just creates logistically speaking, it's harder to accomplish, especially again when it comes to wanting to say something that takes a long period of time to actually happen. Like developmental changes would involve someone or the lifespan of someone from birth to death. Now, again, non-experimental research is important because, as we just said, some experiments are not able to fully capture the complexity of real life. And as we'll see in some of our future chapters, specifically the one focused on experimental methodology, we'll see that researchers exert a lot of control over the behavior they're interested in. So it's not really reflecting the natural way of the behavior actually happening. And the other thing is that many times non-experimental research is perhaps the first step in understanding psychological phenomena. So we need non-experimental research to set the foundation for future experimental studies. There are various approaches that fall under the umbrella of non-experimental research, and these are going to involve correlational studies, observational research, archival research, case studies, and qualitative research, each of which we're going to discuss in detail. Before we go into depth about each one of these different approaches, it's important that we understand what non-experimental research can provide evidence for. The first thing it can provide evidence for is frequency claims. So this is going to be a little bit more about describing the human behavior, like how often it's happening or what percentage of people is demonstrating this human behavior. The second thing is going to be association claims, which refers to how variables relate to each other. Now, one important thing to say here is that this does not imply cause and effect relationships. We'll see that experiments are the only one that can say why behavior happens, which again is a cause and effect type of relationships. Whereas here, this association claims, it's more about, again, how they are relating to each other. And we're going to see a little bit more on this later on today. And this is the main limitation of non-experimental research, that there's no way for us to say that one thing is causing another thing. The most we can do, again, is describe what is the relationship between those things, or describe in general what the psychological phenomena is. Another thing that is important for us to quickly talk about before we get into more detailed information for each one of those approaches that we're going to be reviewing today is the difference between research design and data collection methods. Research design is going to refer to the overall strategy for answering research questions, whereas data collection methods will refer to the specific techniques that are used to gather information from participants. Now, another thing to understand about data collection methods is that those methods can serve different research purposes, and that some of these techniques or methods are more common in certain research designs than others. Now, what research design and data collection technique you decide to use for a study, it's going to depend on the goal of the research question. So again, whether you're trying to describe, predict, or explain human behavior, and then the specific type of behavior that you're interested in. And in this case, we're kind of referring a little bit more into what are the observable indicators that you have decided are going to be what you will use as a part of defining the construct of the behavior that you're interested in. The first that we're going to be discussing today are correlational studies. And a correlational study is going to investigate the relationship there is between multiple variables without any manipulation. So again, because we're not manipulating anything, we're not able to imply any kind of causation. We are simply able to tell whether various behaviors are connected to each other or they're happening together. Now, we can make predictions on the type of association or connection that these variables could have with each other. And depending on whether we're making a prediction or not, we would use specific terminology like predictor variable or outcome variable. A predictor variable would be the dependent variable in a correlational study that is used to predict the scores on another variable. And the outcome variable is the dependent variable in a correlational study that is being predicted by the predictor variable. Here we have a slide that is showing a scatter plot. This is a graph that shows a relationship between two dependent variables for a group of individuals. We're going to talk first about how to quickly read this graph, and then we're going to see the different types of relationships that these variables can have depending on, again, assuming that we get some specific kind of findings. Now here the scatter plot functions very similar to what you might have learned back in high school or some of your early math classes here in college. We have a y-axis and we have an x-axis. In this particular case, our x-axis is labeled as GPA. So this is your grade point average, and it goes from 0 to 4.5, at least in this scatter plot. On the y-axis, we have the number of hours of TV, and this is specifically referring to how many hours of TV these individuals are watching. Now you see that this scatter plot is labeled as no relationship, and again this is showing that there is no relationship between how much TV you watch and what your GPA is in your current major. We're going to see again how this pattern is going to shift depending on whether there is an association between these variables or not, and what association that is specifically. But before we get moving into that, another thing that I want you to notice are the specific dots that are kind of placed again in this scatter plot. Each one of those dots represent one individual in the data set, and it represents two different observations for that one individual. So we have an observation for GPA, and then we have an observation for number of hours of TV. So every time you see a period in this type of scatter plot, if you follow that period down to the x-axis and see where it hits on the x-axis, that will tell you the GPA information for that individual. And if you look at that same dot and you follow that dot horizontally until it hits the y-axis, it's going to give you the information for how many number of hours of TV they were watching for any given time that they were asked about. Again, with correlational studies, we're interested in seeing how the variables associate with each other. In the previous slide, we had an example of no association or zero correlation, meaning that one variable does not influence the other one in any way. We can also have a positive relationship where this relationship between the variables will be characterized by an increase in one variable that occurs with an increase in another variable. So here we have, again, a very similar scatter plot as we did before in the slide before this one. And again, that one was a no correlation. So what overall visually it was telling us is that it didn't matter how many hours of TV you were watching, it was not impacting your GPA, or it was not associated with your GPA in school. Here we have a positive relationship. Again, when it comes to the scatter plot, you're going to read this very similar to the other one. On the x-axis, you have your GPA. On the y-axis, you have the number of hours of TV, and then you see the dots. And one of the things that I want you to notice, make sure you go back to the previous slide. You'll see that in the previous slide, those dots were a little bit more spread out. Whereas in this slide, they are closer to each other and they're starting to form a pattern that goes down, up. So it's kind of creating a line that goes down all the way up. So the line is moving upwards towards the right of that graph specifically. And that pattern of dots is demonstrating the association between the two variables that we're working with here, the number of hours of TV that this person is watching, and then the GPA average that they have in their school. And in this, again, in a positive relationship, what this is saying is that the more you watch TV, the higher the GPA you have. So again, if you look at that point at the very top, and you follow it down on the x-axis, again, remember the 1 point is one individual. If you follow it down to the x-axis, you're going to be able to see what their GPA average is. So for that one person at the very top is going to be 4. And if you go all the way down to the y-axis until it hits the y-axis, you're going to see that this person watches about 27 hours of TV. Whereas on the other end of this line at the bottom, if we follow that last period, or the one closer to the x-axis, we're going to see that is going to be about 1.7 GPA. And then the number of hours of TV that they're watching, if we follow this all the way to the y-axis, is going to be about 3. So again, for some reasons, this study would seem to indicate, or the findings of the study would seem to indicate, that the more you watch TV, the more or the higher your GPA is going to be in school. Now, this might be counterintuitive, and one of the reasons why this might be the case is because of what we call the third variable problem. And again, this is one of the limitations for correlational studies, because we're not exerting as much control over the behaviors that we're interested in. We don't really know what else might be happening that could be creating this pattern between the two variables that we're interested in. And the third variable problem refers to the presence of an extraneous factor in a particular study that affects a dependent variable, meaning that there could be something else beyond the variables that we're working with, in this case, the number of hours of TV and the GPA, that is affecting, again, the variable of interest, which in our case, this will be the GPA. And in this particular example, for instance, it could be that what matters is not necessarily the number of hours of TV that they're watching, but specifically what type of content they're watching. So again, we're seeing here that the more TV you watch, the higher your GPA. And again, this might be counterintuitive, because maybe that means you're studying less, or not dedicating as much time to getting things done for your school. But if you're just watching educational programs, this might be encouraging your learning in ways that, again, are not shown by me simply asking you about the number of hours of TV that you're watching. So again, a third variable problem is something that it's outside of what we have actually measured that could be influencing what we're interested in. Here we have another type of relationship that we can find between two variables. This is a negative relationship or a negative correlation. And this is going to be a relationship between variables that is characterized by an increase in one variable that occurs with a decrease in another variable. And again, we are working still with the same variables as we have in the past slides. So again, we still have on the y-axis the number of hours of TV. On the x-axis, we have a GPA, but again, now we see that the dots are forming a different pattern. So again, we already talked about a no pattern at all. So the variables were not associated with each other. And then the one that we saw on the previous slide was forming a similar pattern in the sense that the dots were closer to each other and they were almost kind of creating a line. But in this case, rather than going down up, is going up down. And this is implying again a different type of relationship between these two variables. So in the case of a positive relationship, what the data was telling us is that the more TV you watch, the higher your GPA was. In this type of relationship, we have the opposite pattern happening. We are seeing that the more TV you watch, the less or lower GPA you have. Or in other ways of saying this, the less TV you watch, the higher your GPA is. So again, if we were to follow one of these dots, so let's look at one of the ones towards the lower end of this line. So we have a dot that is right. If you follow it all the way down to the x-axis, is going to hit a 4, which is indicating that the GPA for this individual is a 4. And if we follow that same dot all the way down to the y-axis, we're going to see that it's going to be around 10 hours of TV that this person is watching. Whereas if we look at the dot that is more towards the top end, kind of like a little bit hanging on the side of that kind of line that is forming. If we follow it all the way down, we're going to see that the GPA is going to be around 1.7. And if we follow it to the side, heading the y-axis, we're going to see that this person sees about 20 hours of TV. So again, in this case, now we're seeing the more TV you watch, the lower your GPA is going to be. So far, we've been interpreting the types of relationships between the variables visually. So again, we've been looking at this scatter plot. We're looking at the individual dots and we're interpreting the kind of pattern that they're forming to say whether it's a positive relationship, negative relationship, or no relationship at all. However, many times when we actually analyze data, we'll get a correlation coefficient. So this is going to be a score that is going to quantify the strength of the relationship between the two variables, and it will provide the direction of this relationship. Now, when it comes to the direction of a correlation or the relationship itself, it's what we discuss basically. Again, whether it's a positive correlation and both variables are moving together, so as one of them increases, the other one increases as well, or it's a negative coefficient, which is equivalent to a negative correlation, where we see an opposing pattern. As one of them increases, the other one decreases. So again, the direction of a correlation, when we're looking at the correlation coefficient, is going to be based simply on whether the coefficient is positive or negative. If it's positive, again, is going to denote a positive correlation and the pattern that we discussed in the previous slides. Or if it's a negative coefficient, it's going to denote a negative correlation and the pattern that we discussed on the previous slides. So this is, again, information that we've reviewed so far. A new piece of information is going to be the strength of a correlation. So again, we're going to get a score, and this score is going to be a value between -1 and 1. And those are the only possible values when it comes to a correlation coefficient. But those values, or that score, is going to tell us again the direction based on whether the score is positive or negative, and the strength based on the size of the coefficient. And again, it can only go between -1 and 1. If you have a +1, this is a perfect positive correlation, and this is the strongest correlation that there can be between variables. If you have a 0, this is a no correlation, so you would see visually, you would see a similar pattern to the first scatter plot that we were exposed to, where you don't see a specific pattern being formed by these dots. It just scatter all over the place. And if you have a -1, this is a perfect negative correlation. And this is also the strongest that a correlation coefficient can be. So one thing that you need to have clear is that the sign of the coefficient only tells you the direction of the correlation. It doesn't tell you anything about the strength. Because, for instance, in this case, the strength of a +1 and the strength of a -1 is identical. Because what matters in a correlation coefficient is that the closer the values are to either -1 or 1, the stronger the relationship between the variables is going to be. So again, for the correlation coefficient, you're going to see values that are going to range from -1 to 1. If you see a correlational value or a correlational coefficient that's outside of this range, that's impossible. Now, within this range of values that you could possibly get, again, you could get some negative values, some positive values. The negative and positive only indicates the type or direction of correlation that you have. Is it a positive correlation? Is it a negative correlation? The strength is based on the actual number that you have for the correlation. And again, the closer you are to -1 or 1, the stronger it's going to be. The closer you are to 0, the weaker it's going to be. But the sign itself does not tell you anything about the strength, because again, +1 and -1 are equally strong. It's just that one of them is a positive correlation, the other one's a negative correlation, and they represent a different type of relationship between the variables. -3 and a +3 are going to be exactly the same strength, except that the type of correlation is different. A -3 versus a +1 or 0.1 is going to be bigger. So the -0.3 is going to be bigger than the +1, because -0.3 is closer to -1 than 0.1 is to +1. So again, the sign doesn't matter, the number does, and that is going to be the closer to -1 or 1, the stronger the relationship will be. Correlational research does not establish causation. Again, it doesn't explain why behavior happens, but it does give important information by letting us know how variables are associated to each other. So it does allow us to make certain predictions. It allows us to test theories and continue developing them. It allows us to identify risks and protective factors. It allows to understand individual differences, again, especially those things that cannot be easily manipulated, like personality traits. And it's very helpful in generating hypotheses for experimental research. So again, one of the things we said earlier is that with non-experimental research, it helps us lay the foundation to see what's actually out there and whereas it's worth doing an experiment or not on it. Moving on now to observational research, which is the systematic watching, recording, and analysis of behavior as it naturally occurs. It is intended to capture behavior as it actually unfolds in real-world context, so outside of the lab. Now, there is something to emphasize here. This is referring to scientific observation, which is not the same as just simply people watching. There is a deliberate structured approach to how we're going to observe this behavior and record this behavior. And this is why we say that this is a systematic process, a systematic observation, because it's going to be a type of observation that requires training, as we'll see in a couple of slides. There are different approaches to observational research, and what this means is that there are different types of observational studies that we can do. We can have a structured observation where researchers put people in specific situations to see what is their natural behavior under those situations. We can have participant observation, which is referring to a researcher actually being an active participant in whatever kind of context that they're interested in. And then we have naturalistic observation, which is going to be the main focus for us in this class as we discuss observational studies. In naturalistic observation, it refers to watching behavior in natural settings without any intervention or manipulation by the researcher. So the main goal is to make non-invasive observations of human behavior, and the researcher is going to try to be as undetectable as possible when making these observations. This type of studies would typically require the development and usage of a coding scheme, which is going to be a list of categories and subcategories of specific behavior so that we can quantify a behavior. So things like the number of times they engage in a specific action or the amount of time they spend doing something. I'll show you an example in a couple of slides. Now, the coding scheme, though, is going to depend on the operational definition of the behavior. So remember that the operational definition really helps us move from abstract constructs to concrete measurable actions, because part of the operational definition is going to be deciding what are those observable indicators that, as the term says, we're going to be observing as a measure of the construct that we're interested in. Now, the quality of observational data depends heavily on the observers who collect the data. And as such, we need to make sure that the observers and the raters must be trained until coding system mastery and have ongoing supervision to assure adherence to the coding system. So this means that they're going to go through multiple rounds of practicing making those observations and getting familiarized with the actual coding scheme. Again, I'm going to show you one. That one's very simple in comparison to what a coding scheme typically looks like or can look like. If possible, I'll post an example of a coding scheme that I've used for some of my studies so you can see how extensive it can actually be. But again, the observers or the raters that are going to go out there to look at people and observe this behavior, they first have to become extremely familiarized with the coding scheme itself, all the, again, categories and subcategories. And then they go through multiple rounds of practice of all of them observing behavior and then coding that behavior under one of these categories in the coding scheme, and then discussing with each other to make sure that there's agreement on what is going to be coded under each one of those things. And again, I'll post an example on Blackboard so that you can see how it kind of looks like. Typically, it'll have a description of the type of behavior that will fall under that umbrella category and so on. So that is going to be a big part of this type of studies. Again, that the development of the coding scheme, which, as we talked in one of our lectures, if it's going to involve translating a construct to a variable to an operational definition, it takes time. It takes a lot of thinking to make sure that it's done correctly. Then another big chunk is going to be the training of participants, or excuse me, not participants, of raters in understanding the coding scheme. And then is going to be them going out there, observing the behavior using the coding scheme and making sure that they're staying true to the coding scheme and they're not taking any kind of shortcuts when making this observation. Here we have a quick example of how this might look like. So let's say that as a researcher, we are interested in bullying behavior, and we have operationalized bullying behavior as the intentional acts of aggression aimed at causing harm, distress, or humiliation to another child. And again, once we've discussed the construct, the variable, decided those observable indicators, and we've come up with an operational definition, which again will tell you how the variable is to be measured, then we can start developing a coding scheme. And here again, I create a very quick coding scheme. For you to see as an example, we have two main categories, physical bullying and verbal bullying. And then within those categories, we kind of have subcategories. It's like physical bullying 1, physical bullying 2, physical bullying 3. And physical bullying 1 includes specifically hitting, kicking, or pushing. Physical bullying 2 involves destroying property or stealing, and then physical bullying 3 involves intimidating through physical presence. And you can see that all of these subcategories are related to physical bullying, but they are still different undertones of physical bullying. So it's going to be like the first one is more direct aggression towards the other person specifically. Physical bullying number 2 is more about aggression directed towards things that belong to this person. And then the third one is more like showing the willingness to engage in physical aggression without actually showing or engaging in the physical aggression. So again, it is different flavors of the overall category that we're interested in. And then we have verbal bullying, which we have verbal bullying 1, name calling or insults, verbal bullying 2, which is threats or verbal intimidation, and then we have verbal bullying 3, which is teasing or making offensive jokes, and we have a very similar structure as physical bullying. All of them have to do with some kind of verbal action, but the subcategories are different flavors or variations of how this happens. Again, some of them are just calling you names and insulting you, whereas in other occasions, I'm actually making threats to kind of cause some fear in you. And again, when we are developing a coding scheme, we want to make sure that we are hitting each one of the things and that are at least the major key components that our operational definition has, so that we can have a more accurate measurement of the variable that we're interested in. So again, there is a lot of work that goes behind a coding scheme. The one that I have here is very simple in comparison to what a coding scheme can really look like. Another thing that I wanted to emphasize in this example before we move on to discussing some other things about naturalistic observation is thinking about again the type of behavior that you would actually record through your observations, because the operational definition says that these are intentional acts of aggression that harm another child. So if you are observing children at a playground and one of the children is running because he's playing with, I don't know, other kids, and in the running he bumps into someone and makes the kid fall, it wouldn't be an action that you would count as aggression. Why? Because this wasn't intentional. It was a child who was just running in the midst of playing and bump into this child. Now, had it been on purpose, where the child on purpose run towards this kid and push the kid, then that would go under the behavior that we're interested in, because it was done intentionally. So again, we have to stay as true as possible to our operational definition when we're creating the coding scheme and making those observations and notating or recording the type of behaviors. The advantages of naturalistic observation is that it's going to be the highest in external validity, meaning that it is going to be the closest to seeing how behavior actually happens in real world context. Some of the disadvantages is that, again, with naturalistic observation, we want to have the researcher not be invasive when it comes to the context and the behavior as is naturally happening. But it can be really hard to achieve this. Again, if you are observing kids in the playground, to quantify through the coding scheme the amount of bullying that is happening. But if you're a random adult who's looking at children, that's going to be weird. You're definitely going to call attention. So again, sometimes or many times it's really hard to be unobtrusive. Another thing is that is very time consuming. You would probably have to spend there a couple of hours for a couple of days, weeks, months, depending on the number of observations that you need for the research question that you have. So again, it takes really, really long to do. And then there might be discrepancies between the observers or the raters. So again, we talked about how the training of these raters is going to be extremely important and recommended to avoid these discrepancies, because the thing is, if we want to trust this data, we want to make sure that there's agreement among our raters. If the raters who have been again train on this behavior and the specific key components of it and the coding scheme and everything are in disagreement on what the behavior that they're actually observing is, then I'm not going to trust the findings as much as if everyone is on the same page about what kind of behavior is being observed and measured. Now, there is one way to test for this agreement between the researchers, and it's something that we have already talked about before, which is this inter-rater reliability. Remember, the reliability in general refers to the consistency of results. In this case, the inter-rater reliability is referring to consistency between the different raters that are making observations of the same behavior. So again, we want to make sure that the raters are being consistent in how they are evaluating behaviors, such that the observations of rater 1 are as close as possible to the observations and recordings of radar 2, and then that the observations and recordings of the radar 1 and radar 2 are as close as possible to radar 3. Now, the inter-radar reliability is a score that we calculate through some statistical formulas. You are not required to know any of those formulas or know how to calculate it, but you will be required to understand what this is measuring and in which context it becomes important. Like again, in data that uses multiple radars when observing behavior, especially when we're using coding schemes. Now, for us to trust the results of naturalistic observation, we're expecting to get inter-radar reliability that is 0.80 or 80% agreement among the raters. And then here I have a very quick screenshot of how it would kind of look like. We have 10 questions, we have two judges, excuse me, and then we can see whether they're in agreement or not. So we can see that, for instance, for question 1 and 2, both judge 1 and judge 2 agreed on what was the code for that, but for question 3, there was a disagreement on that. One of them said 2, the other one said 3. So what we want to see is that for the most part, across all the observations they make, they're consistent with the ratings, where they're having similar recording of the observations. Observational research offers unique advantages for understanding human behavior. It focuses on actual behavior versus reported behavior. One of the things we're going to learn, especially on the next lecture, is that sometimes when people report their own behavior, they are not as honest. Whereas if you're observing their behavior, especially if they don't know you're observing them, they're going to actually behave as they would. There's also the observation of unconscious and automatic behavior. They are things that people do that are not aware they do. Like, for instance, when you like someone, you tend to mimic their body language. And again, this is something that we don't notice necessarily, but it's happening. So someone who's externally observing your behavior, your interaction with another person, and it's been trained to make those type of observations, will be able to make those observations. It's not something that, again, you could easily self-report on. Contextual influences, so again, understanding how behavior might change depending on situations or places or across people. Understanding maybe complex behavioral sequences, so your behavior doesn't happen in a vacuum. There's typically a lot of things that are going on at the same time. So observational studies let us see how behavior actually happens when other things are also at play. And then it allows us to look at behavior of populations who can't self-report. So again, think about babies and kids or people with disabilities that are not able to fully communicate. Through their behavior, we can see certain things, right? So for instance, there's been research on temperament in babies. So depending on where the baby cries a lot, or it's more open to going with strangers and things like that, people can tell, or researchers can tell, the temperament of a baby. Next, we have archival data, and these are a specific type of studies that involve the systematic analysis of pre-existing data. And again, I want to emphasize the word systematic. So it's not something that is just done randomly. There is a process behind how this is done that makes these observations more trustworthy. Now, again, this is the analysis of pre-existing data. So typically, it doesn't involve actually going through the process of deciding what measures to use and who to recruit as participants or any of that. But it still has some of the similar procedures that we've talked about before in regards to what is the behavior of interest, how are you going to translate that psychological construct to a variable, to an operational definition, so that we can have observable indicators to look for in the data that already exists. Now, typically, these data sets that are used to or as part of archival data are collected by big agencies like the CDC or the census and some like national health organizations and things like that. Now, especially with the technology that we have nowadays, there are vast amounts of behavioral data that are generated and stored daily. Again, we have various government and institutional records that collect data and put it out there, and it's available for people to access. So for instance, we have data from the census that includes a lot of different information from people in the United States. We have media archives such as television. We have digital footprints such as social media posts. We have research data sets, which are potentially things like longitudinal studies. And then we have personal documents like diaries of people. And just to give you some really quick examples of how some of this data has been used in the past, I know one of my friends, he is an atmospheric scientist, so he does a lot of work with climate and pollution and how pollution moves across different places and all that kind of stuff. And he uses data that's available because the NOAA, I don't know what it stands for, but it's one of the national organizations that tracks a lot of different pollutants and air currents and things like that. And he uses data from those instruments that is accessible to everyone. I mean, he knows how to work with the data. I do not know how to work with that data, but I could access the data. You could access the data. And again, that's what he uses to actually do a lot of his research. And again, speak of what are some environmental phenomena that happens, especially again when it comes to how pollution moves across either a specific region or all over the world. Or I can give you an example from Media Archives where another of my colleagues has done some work on, I believe it was a Survivor online game actually. So it's based on the TV show and it's an online game, and it happens to be that they are transcripts of absolutely everything that was ever discussed in each one of the seasons among participants. And she was able to do some research with looking at that specific transcripts and saying something about their personalities and how those personalities influence the tactics that they use as part of the game, especially those that won the games. So again, there's a lot of data out there that can be used, and there is a level of creativity that is involved in things like this, because you have to be creative in thinking, okay, this is what is available, and this is how I can use it to answer this research question. There are different types of archival research. The first one is secondary data analysis. This is referring to reanalyzing data that was collected for previous research studies to answer new research questions. And this is not uncommon. Many times researchers will add an additional measure or an additional manipulation, or we'll ask again a few extra questions to do other analyses than the primary goal for why they recruited this sample of people and collected this data and so on. Or nowadays with specific movements that are happening within psychology that increase the transparency of how research is being done, a lot of our hypotheses, materials, and data are being posted online, so other researchers can access my data, and they can use my data again to answer their own questions. So this is not uncommon. Another way is content analyses, and this is going to be more on the end of spoken or written records. So we're not talking about numerical quantitative data. That's going to be a little bit more on the secondary data analysis, although secondary data analysis can be quantitative or qualitative. The main idea is that the data was collected originally for one purpose and then is going to be used now to answer different questions in general. But content analysis is a little bit more towards qualitative data, and again, qualitative data can be videos, can be audio, can be written responses, can be pictures, depending again on what behavior you're interested in and how the data was collected specifically. Now, when you're working with something like that, so again, if it's audio or a written record, typically the usage of a coding scheme will happen. And again, the coding scheme is going to dictate to an extent what are you going to be looking for in those written responses to quantify in a way what is happening. Now, something that I do want to emphasize here is that coding schemes can happen or can be developed before or after the data have been collected. In the case of naturalistic observation, the coding scheme is developed before you go out there and make these observations, whereas in content analyses, typically the coding scheme is developed after, or is developed before you analyze the data, but then as you're looking at the individual responses, you are improving the coding scheme based on what you're actually noticing from the responses that you're reading. This process is resource intensive and time consuming. And here I have an example of archival data and some real research. There are some people that have looked at police reports of homicides. And again, what they were doing is that they went into the records of a police station and they were looking at all the homicides that had happened within a specific range of time. And again, they're reading the reports that the police officers made for each one of these incidents, and specifically they were interested in what were the reasons for why the homicide was committed. And one of the things that they noticed is that for men who murder other men, one of the main reasons for why the homicide happened was because there was some kind of offense that was taken, and it was in retaliation to that kind of offense. And again, this was done just by looking at data that already existed and somehow quantifying, again in this case, the various reasons for why it resulted in a homicide, and then seeing which was the most frequent. So again, when we talked about non-experimental research, I said there's two types of claims we can make: frequency claims or associations. And in this case, you can do a little bit of both because you're quantifying how many different times each one of those reasons came up. In this particular case, offenses or being a victim, quote unquote, of an offense is what led to the most homicides. The next are case studies, and case studies involve intensively studying one single individual, a group, an organization, or an event. Now, oftentimes, case studies are exploratory because the main goal is to learn as much as possible about something that there is very little known about. And as part of a case study, it is typical that researcher will use various methods. So, for instance, you may use observation, so like an observational study kind of stuff. You can use like archival type of data collection. You can use surveys. We haven't talked about surveys on this content or lecture, but we will on the next one. So again, the main idea is that they're using all different types of methods to study the 1%. And typically, the reason why we're only looking at one individual or a very small group of individuals is because we are dealing with something that is really rare. And I'm so sorry here. I see some of the slides were flipped. So to finish archival data, excuse me, advantages and disadvantages of this type of methodology. The biggest advantage is cost efficiency. So the data has already been collected, which means that when it comes to resources and time from the researcher on that end, it has already been done, which is amazing. But it's also unique in other ways, like it can provide historical data, typically because it's done by really big agencies that have a lot of access to people and resources. We're working with large sample sizes. It often has to do with naturalistic data, so we're not intervening in any way on the observation of this behavior. And then many times, again, these agencies follow big groups of people across time, so we have some longitudinal perspectives. I know of a very interesting study that a researcher is doing using some volumes from Harvard University. So Harvard University keeps a really detailed record of alumni, and they have volumes and volumes and volumes of students. And for each one of the students, they have things like what were they doing when they started their respective programs or careers at the university, and then they follow them, like 10 years after, 20 years after, 30 years after, to see what they had accomplished and what their life was like then. If they had kids, were they married, did they change career or jobs or things like that. So there's a lot of information on individuals across multiple periods in their lives. And this researcher is using a lot of this information to study attachment styles. I'm not sure exactly how he's doing this, but it's a very interesting way, again, of utilizing data that was collected, not for those purposes, but again, he's doing something. And again, in that example, you can see that is large sample sizes, it's naturalistic data, and then again, it's longitudinal because he has decades of information for each one of those people. Now, some of the disadvantages, though, is that you have no control over how things were collected. So especially, again, in what indicators you were interested in. They might have used a different operational definition that you had. So this is close to what you wanted, but it's not necessarily what you were hoping for. What was collected again and how it was coded. And then another thing that it's more along the lines of ethical considerations would be like whether there is consent from participants to access the data or use their data in other ways than the original purpose. Now, I do have to say that many of our consent forms typically now inform participants if their data is going to be used for secondary data analyses. And that is, again, included as part of the informed consent, especially as now, again, there are these movements of transparency, and we are expected as researchers to post a lot of this data online. Of course, this is after removing all identifiable information from the data set. And if participant says no to that, then of course, that's where it ends, and these observations are either completely eliminated or they're just not posted for other people to use. Okay, so now going back to case studies, and as a quick reminder, because I know there was an interruption there, case studies are an intensive observation of an individual, typically because, again, it involves a really rare case or it's just something that is really hard to study otherwise. Now, here we have a couple of examples for case studies. On one end, you can see this lady, and I forget her name, but she has a condition that they call like a thin gene. So she has very small appetite, and it doesn't matter how much she eats, she just gets full quickly, and she remains extremely, extremely thin. And she has been observed extensively, again, her actual behavior, her psychological, mental well-being, and of course, biologically. She has had all kinds of tests to see what is going on specifically with her that keeps her thin. Now, as we'll see, I think on the next slide or 2 slides from now, we're going to talk about the advantages and disadvantages of case studies as well. And one of the disadvantages in general is that this cannot generalize to everyone. You and then me and some of your classmates, we all have a normal appetite. Our weight does fluctuate depending on what we eat and we don't eat. So her specific findings or data is not going to apply to us necessarily. But case studies are really good in shedding light or insights into potential solutions or lines of research for other things. So a lot of the work that is being done with her specifically is done in the hopes of finding something that can be helpful for people to lose weight, as we are actually experiencing an overweight pandemic. Then we also have an example on the top where you see slices of brain. And there have been studies that are comparing the brain of dead people who had one condition over another condition, and they're trying to see whereas there are differences between the brain structures depending on, again, whether they had that condition or not. Now, this is considered a case study because typically you won't have that many people that will be willing to donate their body for science so that they can do something like this where they can cut their brain and look at the structures and all that kind of stuff. And then on the bottom we have another example of someone writing on their diary, and again there's been some studies on looking at the diaries of people who committed suicide and seeing what were the thoughts that were happening when, well, before they made such decision. This is another example that I find extremely interesting. You have the link there if you want to read the full article. But in this case, we have a woman who can smell the onset of Parkinson's disease. And it started because she started noticing a smell on her partner. And she was kind of like, you smell nasty. You smell so bad. Like, what is that smell? And eventually, her husband ended up getting diagnosed with Parkinson's. So, of course, as he's getting, treatments, she starts noticing that when she's around other people that have Parkinson's, she smells that smell that she first recognized in her husband. And someone, gets a hold of this information and they start working with her and doing experiments with her specifically. She's the only participant in this case. And they do experiments where they'll give her t-shirts to smell, for instance. And she has to say, this person has Parkinson's, this person does not have Parkinson's, this person is going to develop Parkinson's. And they see that she's actually very accurate in saying, again, who has Parkinson's, who doesn't, and predicting who's going to develop Parkinson's eventually. So again, she seems to have some kind of sensitivity to Parkinson's through her sense of smell. And now that's being used to develop a, what's it called? Like a procedure to detect Parkinson's. And again, crazy how it was just one person's experience, very rare case, which again is typical in case studies, that again, her specific situation is not going to apply to you, it's not going to apply to me, but what we learn by heavily studying her can lead to new lines of research, new ideas to explore that can help a lot of people. Because now, again, the technology that is being developed on being able to detect Parkinson's through this new thing through their smell is what's going to help a lot of people get diagnosed with Parkinson's, especially early in the process. So the advantages of case studies is that, again, we're going to have rich, detailed data. There's going to be so much information about that one individual or that small group of people that there are so many different things that we can understand from that one person. Again, we're also typically dealing with very rare phenomena, and it serves not so much for directly translating these people's experiences to our own experiences, but to generate new ideas. Again, it's a starting place for various investigations. It provides clinical insight, especially depending on specifically what you're studying. And it's important just to have a historical documentation of things that are happening. Now, again, some of the disadvantages, as I've already mentioned, there is limited generalizability, meaning that it doesn't apply to everyone. So again, their experiences are not going to reflect our experiences. They are typically rare cases. So it's not as directly beneficial. But again, we said the advantages is that it does give a lot of inspiration for new research questions to be asked. There could be some researcher bias. It's like, are you only observing or measuring the things that you know are going to support some of your ideas? There is a lack of control, and then retrospective bias, which retrospective bias refers to typically, a lot of the information that we get from these participants are based on what they self-report happened to them, and they have to think back in the day, when you were a kid, how did your parents treated you? And because it's been a long time, it's not as accurate as if you were to tell me what is happening to you right now. Lastly, we have qualitative research. Qualitative research is going to be an approach to scientific investigation that seeks to understand the meaning, context, and subjective experience of human behavior. So remember, this is when we're talking about using audios, videos, photos, written responses. So again, anything that doesn't have to do with a quantity or a specific score or number or something. Some of the goals of qualitative research are understanding rather than explaining behavior, describing rather than predicting behavior, discovery rather than verification, and then particularly rather than generalizability. Again, we're trying to really get into the depths of human behavior, and we want to understand those nuances of human behavior more than trying to quickly quantify something and make quick predictions about something. And similar to what we said about non-experimental research and experimental research and how both of them are important in its own ways because they do answer different questions, but together they kind of create this full picture of the psychological phenomena that you're interested in. Qualitative research and quantitative research are going to do a very similar thing. And qualitative research is primarily ideal when, again, you have research questions about the meaning, about the actual experience of going through something. So again, I can say, or I can ask a participant, from 1 to 7, how much emotional pain are you experiencing right now for your breakup? And someone can tell me a 7, like I'm super sad. Or if I want to understand the experience of a breakup, I can ask them like, what are you thinking about right now? What do you feel like is making you sad? What is it specifically that you miss about him or her and so on, so that I can actually understand the experience rather than just simply quantify it. Qualitative research is also ideal for exploratory research, especially when it's things that we don't understand very much. So again, any kind of topic that doesn't have a lot of research done on it. To understand complex social phenomena, again, there's a lot of things that, um, or I should say, there are very little things that happen on a vacuum. In reality, our behavior is an interaction of many things going on at the same time. Qualitative data is better in trying to see how multiple things are happening at the same time. Ethical considerations, there are again some things that we just simply cannot do. So again, I cannot manipulate you to be in an abusive relationship. That ethically would not be correct. So instead, what I can do is just talk to people that have been in abusive relationships and try to understand their experience. And then the participants' perspectives are prioritized. So again, we want to know from you how this experience was for you. So with this, we finish uh, with today, and then tomorrow we'll do survey research.